Good afternoon. My name is Scott Bybee. I work for DAI Source. DAI Source is an IBM Premier Platinum partner and works with all things IBM, software, data and analytics, security, the list goes on and on. I am the practice lead for our automation practice. We resell IBM software, we provide services, we provide advisory services, we provide professional services, we provide managed services, all things to deal with IBM software. So today I want to focus in on a particular software solution within the IBM automation portfolio, within the AI Ops family. It's called Turbonomic. And in particular, DAI has written an extension to the solution of Turbonomic, and it's called TurboFormation. Now, I will not go into great detail on what Turbonomic does. This video assumes that you're familiar with Turbonomic. We're going to go into technical detail, including a demo of what this TurboFormation does within Turbonomic. Turbonomic, it's basically, I'm not going to get any deeper than a high-level splash. It's this optimization tool on-premise or in the cloud that's constantly looking at your environment and trying to find that equilibrium between cost and performance, making action recommendation to, in the case of, for example, VMs, if we're under provision, to bring that up and execute in a way to resize that VM to allow for it to handle the workload, or if it finds a workload that's over provisioned and it can see they can save a little money, it will then execute an action to be able to size that VM down. It doesn't just work with VMs, of course, volumes, Kubernetes, all kinds of elements within a public cloud or on-premise. And of course, there are all kinds of nuances it takes into account your billing, reserved instances, et cetera, et cetera. But I don't want to get into all those nuances. I want to talk about TurboFormation. TurboFormation is an extension. It has a command line interface from DAI. And we are focused on those set of organization and customers that are leveraging infrastructure as code in the way that they deal with their environments. We've initially written this tool in a way that it works with Terraform. In the future, we hope to work with various other tooling, maybe for AWS example, CloudFormation and so forth, so that we can achieve the same results working with whatever tooling you're provided. But in this demonstration and the current iteration of TurboFormation, we are working with Terraform. What it's addressing is Turbonomic is great at looking at that runtime, making those optimizations, polling all the time, making those recommendations on an ongoing basis. However, in the case that you destroy that environment and rebuild it, or you may be a part of an organization that is not allowing changes to be applied except through a control process that is the infrastructure as code that is leveraging Terraform to apply those changes. So we need to get those recommendations out of Turbonomic and into Terraform is basically what it boils down to. Some use case scenarios might be a QA environment is being built, but it's on a leased basis, it's ephemeral. You do your testing and then it's destroyed, be it an hour from now, a day from now, a week from now. Those Turbonomic is tuned into that environment, it's making those recommendations, but the moment it's destroyed, those recommendations are wiped clean, you rebuild it again, and it has to start from scratch to make those recommendations again. So TurboFormation is pulling those recommendations back and updating your Terraform templates so that the next time you build that environment, it takes it into account. There are some features I want to highlight, and then I'll get right into the demo. We have a command line interface, and I will show in the demo how we pull those recommendations to Turbonomic to update Terraform. We also have worked in a second iteration with the action script integration that Turbonomic provides through what's called an action script target. And we leverage the pre-execution and the workflow to add a call to TurboFormation to make sure that every time an action is executed within Turbonomic, it is constantly updating that recommended action that it's about to take. It's updating the Terraform scripted environment so that the next time that's built out, it takes that into account. Now, let's go straight to the demo. Let's move these slides out of the way. We have several instances running in AWS. I have several instances running in AWS for this demo. These are the names of the instances. We can see they're of type T2 micro. I'm going to get into Turbonomic. Again, I'm not going to give you a tour of Turbonomic. There are plenty of resources out on the internet. Just Google and you can find that describe Turbonomic. I'm going straight into the action recommendations that it has already identified. So these instances have been running. It sees that they're T2 micro. It sees the loads on it. And it says, hey, you should be moving these instances. So it has an action recommendations for a cost savings perspective to move from a T2 micro to a T3A micro. And the cost impact is $1.61 per month savings on that particular VM if we execute this action. Now, granted, that's peanuts, but you'll get other recommendations. This is just a demo environment, and it's free for me. That's why I'm doing it. So $1.61 will save, and we'll have that every time we build out these VMs. Now, let's go to the command line. Oh, just to round it out, I've got this TurboFormation checked into Git, and all the Terraform scripting stuff and the templates and stuff are also checked into Git, so that we're source controlling the way that environment looks, so that we can roll back and so forth. So let's get into the command line. Let's start with the main execution interface, command line interface called Terraform.sh. Let's look at the arguments. We can name the resource type. So a DB server, VM, volume, pod. We're going to focus in on this case in VMs, and we're going to pull back in the first example scenario in my demo, the recommendation to move from a T2 to a T3A. We'll look at that in just one moment. And then we've got these different modes. We can list those recommendations. We can update, which means update Terraform based on the Turbonomic recommendation. We can create that resource. That's a call to create. It's a Terraform call, or we can delete it. That's another call to delete that resource. Now, let's go ahead and execute the update. So let me just look at my history. Oh, before we do that, let me show the resource tree. Otherwise, you can't be 100% sure that I've actually pulled back and updated the too many T words, by the way, the Terraform environment properties. So in this case, they're YAML files. I have a resource tree. It's divided by resource type. We've got a VMs, and then we have a YAML file per VM. And you can see in here, we've currently only tagged it for the size, and we can see that it's tagged as a T2 micro. When I run this update, it's going to update that T2 micro within that YAML file to a T3A based on the recommended action coming out of Turbonomic. So let's look at our history. Let's find a similar line to what we're trying to do. This is the exact line we're trying to do. So let me copy this, save us a little bit of time, pull this up a little bit so you can see that. It's right at the bottom. Maybe I can do a little effort to make it a little better here. Pull that down, pull that up there. Now we can see it. Now we're missing the E. So if we look at this Turboform with the arguments here, we have an argument of the VM name. Turbo instance is the VM name that we saw in our AWS environment here. And we see that it's running at T2, but we have a recommendation for T3A. So it's going to query the API, the Turbonomic API. It's all framed in Ansible. We make an API call out to Turbonomic, and we pull back that recommendation. It says that new entity is a T3A micro. If we look in this directory again, we can see by timestamp that this file has been recently updated. And if we open up that file, we can see, it helps if I put the letters VI in front of it, we can see that it is now marked as a T3A micro. Now, if I go into this instance here, I check this box and I say instance state, terminate instance, and I say terminate. We will destroy that, and when I go to create it from the command line, you'll see that it gets created as a T3A micro. Now, while we're waiting for that to shut down, I want to start to set the stage for the second use case scenario, and this is all going to take place with the Turbonomic. We have what's called an action script target that we've set up that communicates with this server and this command line interface environment. And through what's called policies, we have a user-defined automation policy that updates Terraform. And when I hit edit on this, I can see the workflow associated with this. We can see before execution, we update Terraform. But for the actual execution, we're going to use the native way in which things are executed. So an important point here is that we've injected, in a nutshell, that you need to call TurboFormation, our command line interface, to update Terraform anytime an action is executed. And that's what this policy is handling via this action script integration. Okay, and so we'll get to that in a minute. Let's see if our environment has terminated. It is gone. Let's go back over here. And now we see that again in the resource tree, we've named it as a T3A micro. We will quit and we will look at our history again. We will call the same command line. We know it's gone. And instead of update, we will say create. It pulled from that resource tree that is now a T3A, not a T2. And when it's running, obviously, Terraform, that's the argument it's running to create it. You can see here, it's telling it use type T3A. And so that creation has taken that recommendation. If I refresh here, let me go to any state. And it is now recreating well, it should be anyway. It's really slow. Let's see. It's still running. It should create Terra Turbo instance as T3A micro. It's taking its sweet time to do so. Let's leave that running. I don't know why normally it runs much faster than that, but let's move on to the second case and wait for it to come back there. It's there now. It's still initializing. You can see initializing, but we can see the key takeaway is now a T3A micro. So again, we pulled that recommendation down via the command line. We've updated our Terraform resource tree that's tied to our templates. And we've recreated it as T3A micro. Now, the more relevant use case is you've got Terraform working and you've set the actions to automatically execute. We are now going to look at this, these actions that it's recommended here. Let's go into our AWS account. Let's go into the these. We did this one. It hasn't caught up and re-identified. It'll show up, give it 10 minutes or so as a T3A micro now that that's changed. But we have another instance here called Terra Turbo Instance 2, and it also has a recommendation of moving from a T2 to a T3A micro for savings reasons. If we click on it, well, let's go to the action. What we can do now is we go to the details on this action. We can now execute that action. Now, when that action, it'll use the native way, but it'll have a pre-execution phase that will go through and update that Terraform resource tree so that it now takes into account that change to a T3A. So if I hit execute action, we're using the native way, and we're going to go through, and it's going to end up start to execute that action in progress. It's using that action script interface to be able to interact with TurboFormation. In this case, we log it because we can't see it on standard out, and we go into logs and we can see what logs we see. That we can see that there is a 21:22. Don't know what time zone this is, but that corresponds to a minute ago. Let's look at what this log is showing. We can see at the bottom that it has updated to a T3A. Let's go into the resource tree, and what we should find, resources, and we go into VMs and we list here, and we see that this has also been updated. It was a T2. And we can see now that it is going to be a T3A micro. So it is executing that automatically. It probably has already started the process of regenerating it, and it has. You can see that it's set it to a T3A, and that's all Turbonomic. It's doing all the work. But in that execution phase, we did a pre-execution phase to say, hey, before you do it or as you're doing that, let's just pull back the output. It comes in as standard input to the TurboFormation framework, basically the payload, which is a JSON payload that shows what that action is doing. We parse that payload, we pull the recommendation that says it's going to a T3A micro, and we update our Terraform environment. So that really concludes the demonstration. In a nutshell, the goal is to allow for people that are really bought into this infrastructure as code approach to have a way to tap into Turbonomic so that we make sure that all those great recommendations it's making are making their way back into our Terraform scripted environment. I appreciate your time. If you'd like to contact me, my email is sbybee@daisource.com. Feel free to email me. Happy to show you more about the tool. If you're not familiar with Turbonomic, I'm happy to give you a demonstration of that as well. A great tool from IBM, and we've got a lot of clients that are really saving a lot of money and benefiting from the tool. Anyway, I appreciate your time. Thank you. Bye.